Hello people, today we are going to learn about compound inequality. So let's see. What are compound inequality? When two simple inequalities are combined into one statement by the words and or, the result is called compound inequality. For example, all real numbers greater than 2 and less than 6 can be written as x greater than 2 and x less than 6. And on number line we can plot it like this: 2 to 6 and not including 2 and not including 6. Whenever this is dark like here, that means we are including the 2. If we have not mm, filled the number, that means there is no dot here, that means it is exclusive. Here the 2 is inclusive, that's why there is a dot here. 6 is also inclusive, that is there is a 6, there is a dot here. So let's see the next example. All real numbers greater than or equal to 2 and less than or equal to 6. So x greater than equal to 2 and x less than equal to 6. That means 2 and 6 are inclusive for x. So there is a dot here on 2 and there is a dot here on 6 on number line when we are trying to plot on the number line. All real numbers less than 2 or greater than 6. So less than 2 or greater than 6, it does not say equal to. That means these 2 and 6 are exclusive, so there won't be any dot. It should be open-ended. That means x is less than 2. That means x is less than 2 but not including 2. X is greater than 6 but not including 6. So that's why less than 2 go this side and greater than 6 goes this side. It says or. That means there are two solutions. Either x can be less than 2 or x can be greater than 6. All real numbers less than or equal to 2 or greater than or equal to 6. Here it says equal to. That means it includes 2 and less than 2. And here it says greater than or equal to 6. That means including 6 and greater than 6. So we can write the symbol as x less than equal to 2 or x greater than equal to 6. We can plot on the number line including 2. So there is a dot on the 2, including 6. So there is a dot on the 6, and greater than 6, including 2 and less than 2. Let's see example of Venn diagram. In this diagram, oval A represents some integer solution of x less than 10. So A represents x such that x is less than 10, and B represents x such that x is greater than 0. So all the numbers which is greater than 0 is included in B, and all the numbers which is less than 10 is included in A, and the number which overlaps for both of them are both greater than 0 and less than 10. So this 1 2 7 9 is both included in both the sets A and B and satisfies both the criteria, that is x is greater than 0, all the numbers here are greater than 0, and x is less than 10, all the numbers here are less than 10. So this is how we can plot it on the Venn diagram. This is, and then if we want to plot it on the number line to find the solution, here is the solution. First number line represents x less than 10. So this is 10. Less than 10 means on the left hand side, moving towards left hand side. And since the 10 is not included, so there is no dot here. Second one represents x greater than 0. Since x is not it doesn't say it's equal and greater than 0. It just says it's greater than 0. That means not including 0. So not including 0, x is greater than 0, so it moves to the right hand side. And the solution for numbers which is solution for by combining both the inequalities is x is greater than 0 and less than 10. So the intersection will be the overlapping region is called intersection, and this starting from 0 to 10, not including 0 and 10, is the solution. So from here to here, 0 to 10, not including 0 and 10, is the solution of the intersection, the overlapping region. Let's solve these two examples. It says minus 5 is less than x plus 1 is less than 2. So what we can do is minus 5, if we take this 1 this side, then it becomes minus 1. Minus 1 is less than x, and this 1 to on the right hand side, then again it goes 2 minus 1. So less than 2 minus 1. Again it can become minus 5 minus 1 makes minus 6, less than x is less than 2 minus 1 is 1. So the solution is minus 6 is less than x is less than 1. That means x is greater than minus 6 and less than 1. So again we can plot it on the number line. It does not say equal to, that means x is between minus 6 and 1, not including minus 6 and 1. So you can easily plot it on the number line. Let's see, let's say this is minus 6 and this is 1. So when plotting on the number line, we can say this is the solution is minus 6. It's between minus 6 to 1, but since this is not included, we will not fill the dot. We'll just draw a circle which will signify that not including minus 6 and 1, the solution is between minus 6 and 1. So the solution is x is starting from minus 6 to 1, not including minus 6 and 1. Similarly, we can solve this example. We will bring minus 1 to this side and minus 1 to this side, both the sides. So when you move minus 1 to the other side of inequality, the sign always changes. So minus 1 becomes plus 1, 3x, and again minus 1 to this side, less than, this is less than and equal to, when you move the minus 1 on the right hand side, again the sign changes, which makes it plus 1. So now it will be 9 less than 3x less than equal to 12. And now we have to remove this. If 3 is multiplied by x, whenever a multiplication moves to the other side of inequality, it becomes division. So 9 divided by 3 is less than x is less than equal to 12 divided by 3. So whenever we move a number to the other side of inequality, the addition becomes subtraction, subtraction becomes addition, multiplication becomes division, and division becomes multiplication. So remember that rule. So 9 divided by 3 is 3, is less than x is less than equal to 3. 3 4s are 12. So 4. So the solution here is x is greater than 3 and less than equal to 4. So how we can plot on the number line? Here it says x is greater than x is less than and equal to 4. That means including 4. and here x is greater than 3 but not including 3. So let's see how we can plot on the number line. Assume this is 3 and this is 4. So this number line is not drawn with scale, just for the understanding of the concept. So this is including 4. Including 4, that means we are going to fill the dot, which will signify that it includes 4 and it does not include 3. So we will draw a circle, which will signify that it is not included in the solution. So x is greater than 3 and less than equal to 4. X is greater than 3 and less than equal to 4. So this area is the solution for that particular inequality. In this Venn diagram, circle A represents some integer solution of x less than 0, and circle B represents some integer solution of x greater than 10. The combined shaded region represents number that are solution of either x is less than 0 or x is greater than 10. So let's solve this one, which says 8 plus t is greater than equal to 7. So whenever the rule is, whenever we move something to the other side of inequality, the sign changes. So whenever this 8 is plus and we want to move to the other side of inequality, then it will be t is greater than equal to 7 minus 8, because 8 was positive here. The sign changed to 7 minus 8, or again here the sign will change. T is less than 2 minus 8, because 8 here is positive. So let's solve this equation. T is greater than equal to minus 1, or t is less than 2 minus 8 is minus 6. So the solution here is t is greater than equal to minus 1 and t is less than, or t is less than 6. So how we can plot in the number line here? It says t is greater than equal to minus 1. Greater than equal to minus 1 means here it's minus 1. So t is greater than, so it moves to the right hand side. Greater than minus 1 is all the numbers greater than minus 1, which is whenever we are going think about the greater inequality, it always goes on the right hand side. Whenever we want something which is less, we move to the left hand side on the number line. So t is greater than minus 1 moves to the right hand side. T is less than minus 6 is this. Here minus 6, it moves to the left hand side. But it says not equal to 6 but less than minus 6. Here it says including minus 1 and greater than minus 1. So the answer will be like a union of both the solution. So t is either less than minus 6 or greater than equal to minus 1. So this is the solution as per number line. Every solution of a compound inequality involving AND must be a solution of both parts of the compound inequality. If no number are solution of both simple inequalities, then compound inequality has no solution. The solution of a compound inequality involving OR are not always two separate sets of numbers. Some numbers may be the solution of both parts of the compound inequality. So this is another problem to solve. We have to write the inequality. So what will be the inequality? Here there is a dot, that means minus 8 is inclusive. So let the number be x, x is x is less than equal to, it says. So less than equal to, I'm using this symbol because I don't have that particular symbol handy as of now. So x is less than, because it is moving to the left hand side of the number line. So x is less than equal to -8, or x is greater than 0, because here there is no dot. So exclusive 0 and greater than 0. So x is either less than equal to -8 or greater than 0. Let's solve this example. This example both exclusive because there is no dot. So -2 is not included and 5 is not included. So the answer is x is greater than -2 and x is less than 5. Or we can write this as -2 less than x less than 5. So x is in between -2 and 5, but not including -2 and 5. So this is the solution. Let's see a word problem. The target heart rate during exercise for a 15-year-old is between 154 and 174 beats per minute inclusive. In the word problem, it always says if it is exclusive or inclusive. Since it said inclusive, so on number line, we will put a dot on 154 and 174 because they are inclusive. And while writing the inequality, we will use equal to, less than equal to, and greater than equal to. Equal to is important for inclusive. Write a compound inequality to show the heart rates that are within the target range and graph the solution. So it says is between, that means x is in the between and less than equal to, x is greater than and equal to 154 and x is less than equal to 174. That means x is greater than equal to 154 and less than equal to 174. That means it's between 154 and 174. So the for graphing the solution on the number line, here it is 154, 174, both inclusive. So there is a dot here, and the heart rate is between 154 and 174. So this is how we graph on the number line for compound inequality. So guys, I hope you got some idea on how to solve compound inequality. Come back to my channel or subscribe to my channel for more videos on algebra and other maths. So thank you very much for watching.